Alright, this is video number 2 for unit number 2, and this is a quick video. All we're going to do is just going to talk about basically what you've demonstrated on the spring. We're just going to put some names onto some of the things that you've done. We're just going to basically define constructive interference and destructive interference, and give you a quick example of a destructive interference. So here it goes. So constructive interference, this is when two waves interfere and then add together. So, for example, if I have a wave, okay, coming on top here, and it's coming this way, and I have another wave coming this way, okay, when they hit, these waves like climb on top of one another. So this is if this were like 1 centimeter, and if the height of this one was 1 centimeter, then the height of this one is actually going to be, there's 1 centimeter, there's another centimeter. It's actually going to be twice as tall. Okay, so it actually hits, okay, and then they climb on top of one another, and then that's called constructive. That's when they get bigger. Like you're constructing a house, they get bigger. Okay, it doesn't have to happen like this. Okay, where they're both on top. You can actually have it like this, both on bottom. They both on bottom. Here, they just add together. It's just upside down. Okay, so don't get too mixed up with that. Now let me say this, and hopefully you pick this up. When the waves pass through one another, so if I were to label this as wave A and this is wave B, when they pass through one another, A then is over here moving this way, and B is over here moving that way. They actually pass through one another. They don't bounce. I think some people think they bounce off one another, then A would be coming back this way, and that's not the case. They literally pass through one another as if they never exist. The other one, they pass through one another as if the other one didn't even exist. All right, the next one, destructive interference. This is when two waves interfere and completely or partially. Okay, so it doesn't have to completely. So either completely or partially cancel out. I'll do some smaller examples here. So let's do an easy one here. So if I've got a wave on top coming this way, and a wave on bottom coming this way, and this is 1 centimeter, and this is 1 centimeter, okay, when they meet, they'll literally cancel each other out, especially if they're the same height. So they'll totally cancel each other out. Now, keep in mind, afterwards, if this is A is going to be on this side, moving this way, and B is going to be on this side, moving this way. Remember, they go through one another as if the other didn't even exist. Alright, and then the other quick little example here. Let's say that I've got one, let's see, kind of exaggerate this one. Let's make this like 3 meters, moving to the right. And then let's make this one kind of like a real short guy here, 1 meter. So when they hit the middle, now they can't cancel one another out. This guy's not big enough to cancel this guy out. So what happens? Well, since I've got a taller wave on top, then when they destructively interfere, this one's not going to be 3 meters high. He'll be 2 meters high. All right. So don't let that confuse you there. They do completely cancel out if they're of equal heights. Okay, if they're different heights, then they partially cancel one another out. Hey, that's the end of video 2. Good luck. Move on to investigation number 2.